Didn't realize there were two start buttons.
Me either. Hey, everybody. Thanks for joining us. Give it a minute for people to trickle in, and then we will get this shindig started. How's everybody's Wednesday going?
Is that what today is?
That it is. Give it one more minute, then we will get started. All right, let's do this thing. So, hi, hey, hello, everybody. Thanks for joining us today. This is going to be our workshop, Living Off the Land from Execution to Impact. This should be pretty interesting today. We've got some hands-on portions for you guys where we get to kind of play around with these different behaviors, test them out in a range. Uh, with that, before we dive in too deep, let's do quick rounds of intros.
Ooh, up first. Hi, everybody. I am Tyler Casey. I'm the lead detection engineer over here at Scythe. I've been doing DCO, defensive cyber operations, for like 12 years now. Yeah, got my socials on there. Thanks, everyone, for hopping on.
And hey, y'all, I'm Trey. If you've never seen my face before, I'm the lead emulation engineer over here. All that means is I'm kind of the red component to Tyler's blue when we're talking all things purple teaming here at Scythe. I've done a little bit of everything throughout my career at this point. If you want to connect on socials, they are on that slide as well. So cool. Now that we got that out of the way, what do we have for you guys? The first piece of this is going to be the hands-on piece. If you did not receive an email from CoreStack with an image that kind of looks like what's on the screen right now, please let us know so we can get you registered. Shoot us a message in chat. But that is going to be how you access the lab environment for today. So as we're getting started here, go ahead and take a second to click on that go to event link there, register with CoreStack if you've never used them before, and spin the range up. The goal here is to be really kind of as short as possible on us chit chatting and more time as we can give you guys to be hands on in the lab environment to kind of play around. So if we feel like we're kind of going fast, tell us we're slowing down. We're just trying to make sure you get all the information as quick as possible so you can have the fun part of this with the hands on here. Okay, Philip Short.
I got them.
All right, sounds good. So what are we talking about today? We're going to go into a quick couple slide foundations about LOLBAS, why it matters, all of that kind of fun stuff. From there, we're going to dive into the different phases of a kill chain and kind of how LOLBAS can be used within each of those phases. And we're going to kind of cover everything from, getting initial execution after you've been on a host, maybe you're trying to get a new implant running, all the way through the actual exfiltration of some data and impact towards the end of your kill chain. So without further ado, let's talk foundations. What is LOLBAS? What does it matter for you guys? So when we say LOLBAS, we're talking kind of living off the land binaries and scripts. And the simplest way to possibly say this is using what's already in the environment on the endpoints that we're targeting to affect operations and complete the objectives that we as the red teamers or those of us emulating the threat actors need to achieve. We're focusing on Windows specifically in today's workshop. If this one kind of gets well received down the line, maybe we'll focus one on Linux and Mac OS. But for now, market share in most organizations is Windows. So that's kind of what we tailored this around. The cool thing about kind of living off the land is Microsoft as an attack surface provides you almost everything you already need for a threat actor. Oftentimes, a lot of their binaries, they're signed by them, they're trusted by default. So they don't really kind of pop any alerts or raise red flags when they're used, especially if you don't have any kind of behavioral analysis or a baseline already set in your environment to understand how your users typically use the platforms, use these different binaries and tools, and kind of spot weird or not. For those of you that have never seen it before, there is a bunch of different documentation out there around living off the land for the Windows specific stuff. Looking at that LOLBAS project at GitHub is a great one you can start with. There's also, was it LOL, living off the land, living off the land. There's LOL farm. There's a ton of different ones, and we can share those with you guys throughout the day to day. But there's a lot of really cool, interesting projects out there that kind of help you guys explore this topic further. The kind of last two pieces here is there's no real payload necessary on disk. You don't need to bring in other tools to potentially, do enumeration or potentially set persistence. You can affect those changes on the endpoint without bringing in your own tooling. So that means there's no kind of like easy signatures for your AV and EDRs to catch. It really comes down to how tuned is your environment to think things are bad or not, and how well do your defenders know the organization and how employees typically operate. Okay. You good with those ones, Tyler? Looks like there's a few more that still need the link. Cool. So let's get moving. What are we going to talk about today? So here's kind of a look at the kill chain and what's kind of going on with our narrative here. We're going to start with, let's say we can call this assume breach, however you want to go about it. Somehow you landed on a user's endpoint, right? You got initial access, but you don't have any of your tooling in place. You don't have kind of like a reverse shell or any kind of other kind of secondary C2 setup. So we're going to use that foothold to kind of get some execution on a SCYTHE implant from there. We're going to move into performing some kind of discovery and enumeration behaviors in a couple different interesting ways. We'll do some privilege escalation, set some persistence through like registry run keys, things like that. And then we'll kind of cover our tracks, clear some logs, try to obfuscate and kind of blind our security tooling, and then steal some data. We've got a lab in this range set up for you guys where you've got your typical host, you've got a domain controller, some AD accounts, things like that, and some stuff on the endpoint to where you'll be able to interact with the environment and perform these actual behaviors. The one thing of note, I would say, as we're going through this, the lab manual is pretty extensive. There's several different behaviors documented for each phase of the kill chain. With this being a 3-hour workshop, I'm unsure right now if everyone's going to have enough time to get through all of them. So the kind of goal here is going to be to highlight these different behaviors for you and give you a chance to practice one or two of them. We don't expect everybody to get through all of it, and I don't believe we're going to have the time to demo every single behavior that we have in here, but we'll still get a chance to go through the different phases and see some of the more interesting or unique ones per phase.
Yeah, this is the first time we're doing this workshop, so we'll see how the time lines up.
So the defender's dilemma. This one, I'll let you talk to a little bit, Tyler, if you want.
Okay. Yeah, definitely the I guess the obvious dilemma of using LOLBAS, living off the land binaries and scripts, and why adversaries like it so much is because it's signed by Microsoft, right? These tools already, or tools, these binaries, tools, scripts, whatever it is that you're using are on the system and enabled by default. They're trusted by Microsoft. They're digitally signed. They're created by Microsoft, maybe. You don't have to bring anything in to run these different tools and things like that. So it can be very difficult to identify what is malicious and what's anomalous when it's something that's designed to be used, right? And we'll get into it more as we get into the actual lab manual itself when we run these and talk about detections and pieces like that. But it's really important to focus on like state-based changes, child process anomalies. By that we mean like does PowerShell, or excuse me, like does Word spawn PowerShell, spawn something else, or does FOD helper spawn and executable in a different location. We'll do that exact example in the lab here in a little bit. So it definitely poses some challenges, and that's why adversaries like it so much.
And what's interesting, kind of tell you'll see in this workshop, our focus here is more on the red side than the blue. But you'll notice through the lab manual and on the slides, we've got some kind of detection tips and hints for you guys as we go through it. The biggest thing when it comes to living off the land behaviors and trying to detect them is focusing on what these tools do, not necessarily what it is. If you're trying to do kind of like stagnant sintering, it's going to break a lot of things. It's going to cause you a lot of headaches and a lot of false positives. But if we focus more on like what it's doing, the changes it's making on the endpoint or in your organization, and those different anomalies, that's going to kind of give you a clearer picture of what's actually happening and spotting bad versus good. So if you guys don't have any kind of quick questions over what we're going to cover today, we can dive into the first phase of this kill chain being execution. Up to this point, does everybody have their invite link for Core Stack now? Got all signed up on that? Okay, let's see.
I got that last
All
one.
right,
I think I added everybody else.
all right, easy. Well, let's dive into execution then. So, what are we talking about here? The kind of the scenario is, let's say you fished a user, you dropped a USB into the parking lot, something like that. You somehow got the user to do a thing. Maybe it was click, like a kind of click fix style attack, something like that. You're on the endpoint, but it's very basic access. You don't have any true C2 or anything in place. You need to run some code, right? So how are we going to do that? Well, Microsoft was gracious enough to give us a plethora of different ways of doing this. But we're going to cover a couple of the more interesting ones, kind of like certutil, run DLL32, and kind of one of the newer ones that we've been playing with, and it's interesting. It's not necessarily new, it's just kind of coming into the spotlight is SCP. So we'll kind of talk through those and show you those today. And speaking of, that's the first one we've got here. So a lot of people don't realize still, which is kind of surprising to me, that as of Windows 10, I think it was like version 1803, like back in 2018, Microsoft started shipping their port of OpenSSH and the corresponding tools. So like the SSH and scp.exe binaries in the endpoints by default. They made it something that you can also on-demand install on servers and other things like that. But for the most part, since that patch for Windows 10 and 11, Server 2019 and newer, SSH SCP is there by default. And a lot of people, when you think about SCP, you're thinking, oh, kind of moving data around, staging things, data exfiltration. And mind you, it is great for those kind of behaviors, right? Because it's encrypted traffic. We're doing this in a secure way. It's really easy to move information around, files, binaries, text, everything, as long as you've got some decent credentials. But the one thing a lot of people didn't realize is SCP can also serve us a much more interesting purpose when it comes to execution. There's a couple different ways, and specifically using the dash lowercase o and proxy command, you can have it run some kind of exe, do a command, do a thing on the endpoint locally or remotely, which is really cool. The other route you have is the dash S to kind of proxy it out. Both options will kind of function the same. The biggest difference here with the dash S is it doesn't like relative paths. So you're going to have to specify an absolute path of the thing you're trying to have it do or execute. But all in all, it's as easy as you see on the screen here. If you can pop a terminal, command prompt shell, anything like that, and issue just scp.exe proxy command, you can kick off and have SCP do something else for you. And that kind of looks really interesting from a detection perspective. You guys will get to try this one in the lab. So I don't want to kind of beat the horse on this one too much and kill it on the first try. But this one you'll have some fun with, I think. It's a little different in the way it works and the way it looks. Next up, we have certutil. I'm sure everyone's heard of certutil up to this point. It's built into the platform by default for certificate management, but it's also got a couple documented switches or parameters that can be provided, being the URI or URL cache or dash decode and encode, where it can handle obfuscated text or strings, and it can also reach out to the web and download information. So this is a really good way to go in, grab data, and execute something, or to download and implant some kind of payload or tooling, something else you want to utilize, and get execution as well. It's been around for a hot minute. This isn't kind of like a new thing, and this is something that should potentially raise flags, but it's not always in there by default because it is used by the system and by administrators for legitimate purposes. And then next up, we have run DLL 32. This one I would say is kind of the tried and trusted method, right? This almost always works in an engagement. I've noticed even up to this point, a lot of the major kind of AV EDR vendors, they'll hammer on executables left and right, especially if you're bringing in your own kind of payload as an EXE. It's unsigned, things like that. They hate it. They stomp on it before you can even fully download it to disk. But a lot of the times, unless you've got your stuff kind of tuned up to 11, it'll let a DLL pass by. It'll let run DLL do some kind of execution, which has been really interesting. And I would say, what, for the last 2, 3 years, Tyler, that's still been the case where we get execution through a DLL, but that same kind of payload as an executable will get stomped on. So using run DLL 32, super easy. You're calling the executable run DLL 32, tell it what DLL you want to execute, and then the entry point of that DLL. So an example of this could be like that first line there, run DLL 32, payload.dll/go, or absolute client name, something like that. If you build out your own kind of payloads, you can usually specify that entry point or go with a default one. You guys will have a chance to play with this in the lab and execute a direct download to a DLL that you can build out with our platform. So that could be pretty cool. You've also got a couple other strategies when it comes to execution from RunDLL 32. It's kind of use of scripting languages, so like using JavaScript as proxy execution or running like COM objects and scriptlets from a URL are also both possible here, as you can kind of see on the screen. I think these are probably the big ones we want to hit on. Did you have anything you wanted to add on RunDLL, Tyler?
All good. We'll get into it more when we get into the labs.
Yes, I'm trying not to eat up too much of their time on this one. So cool. And speaking of labs, let's go into the first one, right? So that was a kind of quick overview, kind of what we're talking about with LOLBAS and a couple execution methods. Did you guys have any questions over that before we dive in? Yes, all of these commands we've shown you by default, you can run as the context of that current user, but you can also do these as like a run as or something else. Like I know with like as a good example here, like for SCP, you can specify the user credentials you want it to utilize, or you could have it bypass the known host or trusted host files and use whatever credentials you have or you want to utilize. You're not tied to just the current user context. All right, cool. So if we don't have any other questions on this one, let's hop in. The first thing we're going to do here, give you guys a quick walk around of what it looks like inside of CoreStack as you registered, access the class. This should kind of be the first page you see. Over here on the left is our lab manual. You can access everything from there. It'll show you the different phases. For this first lab, we're going to go to the Run DLL tab down here. Now, what we want to look at and show you real quick, if you want a quick familiarization, you've never used CoreStack before, we've got a quick little like 4-minute video you can watch. We also have some familiarization and cheat sheets on Scythe and Splunk and a quick little primer on LOLBAS if you guys want to read through those and go through them. They're there more as kind of like a reference for you to perform these behaviors. The key focus for this lab is going to be this execution phase right here. So going from overview down to run DLL 32. To get started, come over here and click on Systems. You're going to hit Launch Group, and that's going to bring up the lab environment for you. Once it pops up, you should see this No System turn to running, and this Connect button will light up from being gray. If you click on the Unicorn host, that'll take you to the initial host we have for you guys to get started on, and we can follow along from there. Make sense? All right, so I think we've initially timed about 20-25 minutes for you guys to go through this section. It shouldn't take too long. What I would pay attention to is for you to run through like the SCP, cert util, and run DLL sections, you need to have some kind of binary or implant to pull down. So what we're going to do in this stage implant and curl sections is show you how to quickly utilize Scythe to set up a quick test that'll give you a shell or just a payload in general that you want to pass. Then we'll use curl. This is kind of out of the way. Yes, I know it's not execution, but this is kind of our way of staging something for you to execute. You'll go through, run these sections in curl, and then you can utilize SCP, cert util, or run DLL32 for that execution. You don't have to do all three. They're kind of there for your own reference. What I would recommend if you want to do that, pick one, kind of focus on it and play through it. And then we'll do a quick walkthrough demo and show these off here towards the end. Any questions? Anybody having issues getting into core stack?
Yeah, so it should take a few minutes for the lab environment to turn on. So before you read anything or do anything else, please just turn on all of the systems because we have a domain controller and Scythe and Splunk in there. So it takes, like I said, it takes a little bit to turn on. The one on there, Trey, if you could click on the cert util one real quick. So on that one, originally when we were developing this course, we were going to download the implant via cert util. But because this is our lab environment, our server doesn't have like an actual signature. It's just a self-signed cert. So there's no way around that with cert util. So to download, please use the curl like Trey was saying. And then from there, you can use the SCP proxy execution or run DLL32 to launch the DLL implant. And then we'll do probably here in maybe 5-10 minutes or so, we'll start going over just the demo of it. We want this first part just to make sure everyone's on the same page and able to download everything. So, said we'll give you guys a couple of minutes, and then we'll start the demo kind of on our side. Feel free to read and experiment, and yeah. Any questions when they come up, please let us know as soon as they happen. Any issues that come up, please let us know as soon as they happen so we can try to get those fixed.
I think from this point, we'll go to work in this first phase till around 13:40, 13:45 Eastern time. We'll check in with you guys throughout it and I'll throw a timer up. If you've got questions, just let us know.
Overall, thanks for pointing that out. Just realized when I was going through building this out that I had my shell open as admin when I did it. So I'm changing all of those paths to go from C Windows temp to C users public in the lab manual right now. So you should see that changed here in a second, and then you'll be able to access that. So my mistake. Thanks for the call out. So yeah, you should see that. Might have to refresh your browser that you're in. You should see the updated paths for the updated commands.
How's everybody doing so far? You guys getting through the first few sections, staging your implant and running one of the execution paths? Uh, Josh, you are correct. We left the cert util section in there as a reference in a typical environment that should work. With this being an internally hosted range, the cert on our hosts are invalid, so cert util doesn't like to play nice. For the sake of expediency and doing it in this lab, we're just having to use curl to pull down the implant. And when you guys get kind of close to done or you finish up the sections you want to play with, go ahead and throw us a thumbs up in the chat or something. That way we kind of get a feeling for who's done, who's still working.
Hey Josh, yeah, so you won't see any feedback in the PowerShell terminal as long as there aren't any errors. If there's an error, you should get an error in there. But what you will get once you run the excuse me, once you run the DLL or execute the DLL, that's when you'll get the check-in on Scythe. So that's what we'll be showing here in a second. And then we're going to use the Scythe implant after this to run the rest of or almost all of the rest of the LOLBAS commands. Well, and I'll demo that here in a second, or here in about 2 minutes. All right, give me 1 second to get the rest of my stuff set up. All righty. So we'll just go ahead and take it kind of from the top. Do stage implant up first. Alrighty. We go back. Say, I'll be doing this in the lab with you guys in the lab time as well. So it'll be a little bit of duplication of effort here, but be able to see it. So the first thing we need to do is make the scythe implants. That way we have something that we can actually execute. So we'll go once you're logged into Scythe. So that should just be on the Unicorn host box. Open Chrome, and then we have a Scythe bookmark up there at the top. Go ahead and log in with your credentials. Be Unicorn and then Unicorn 111 bang bang bang. So the first thing we'll do is build the actual test. So you can give it a name. Mine is already called first campaign. So first campaign one, we'll go next. Then here, we don't really need it to do anything. So we're just going to load the run module, which is going to allow us to execute these other binaries and just do a who am I, right? Just to give it something to do to make sure that it's working and checking in okay. So we'll do who am I, the little drop down, we'll create the test. And then from here, we're going to need to use the deploy test directly button, and we're going to grab these links for the exe, open Notepad, the exe, and then we'll grab the link for the DLL as well. So we're going to download both of them because we're going to use them in two different ways for the workshop. DLL. There, so we have those two. That's all we'll need from that. We'll continue on. So the first thing we'll do after that is to download the implants. So with that, we'll open PowerShell and then just clear that out. Go up. So we have PowerShell is launched, and what we'll do is copy this curl command. You do need the cmd/c. The reason for that is because we're in PowerShell, and the way that PowerShell interprets the curl command inside of PowerShell, not in command prompt, is a little weird. So it's a lot easier to utilize CMD inside of it to call it. So with that, we'll do CMDC, and then this link here that ends in the direct download link, we're going to replace all of that with our direct download link that we grabbed from earlier. So this is the payload .dll. So we'll copy that, and then in there, just change that out, press enter, and it'll download it. I don't know what mine will do because I already downloaded it. Might tell me that it's wrong. Yeah, so because I already have it downloaded, so that's why it's giving me that error. But so we'll do that for both the DLL and the exe. One should be saved as payload.dll, the other one payload.exe. So once we have those downloaded, we'll go over. There's the SCP execution. This you can really utilize to, like Trey was saying before, you can utilize to launch really any application that you have on your endpoint. For this, we're just going to launch calc just to kind of show you that it'll launch something. You could use this to launch your Scythe implant, or if you had any kind of other like malicious malicious executable or anything like that. It's pretty neat because it'll really type on a sign. No worries, man. If that's the only issue we have all day, then that'll be okay. Um, but the SCP execution is, I think, super interesting. Just anything that'll kind of muddy the waters with what your process hierarchy is, I think is super valuable, right? So like this is a super easy detection to break. We just added this last night, so I don't think we have any detections in there. That was kind of a last minute add. But if your detection is looking for like, let's just say calc being launched by PowerShell or something like that, this isn't going to trigger it because PowerShell isn't launching it, SCP is launching it. So super valuable if you're able to kind of interfere with that process hierarchy. But like I said, this is just really an example to show you that it can execute different things. Like I said, you can change it to any executable that you really want. And in there, the cert util, like we said, we just have that in there as just some information. We did the write up, so figured we might as well just leave it in there. It's not going to work in the lab due to that self-signed cert, but it's something you could probably you can mess with on your own if you have something downloaded, something or something that you need to download. You can also utilize it to encode and decode files to base 64, which could be useful for like if you're going to do some kind of exfiltration later on or something like that. You want it to be a little more obscured. You could utilize cert util to accomplish that as well. But to the actual execution piece itself, we're going to use run DLL32 to launch our DLL that we just downloaded a little while ago. So for that, here we go. Ah. With that, we're just going to copy this out, run DLL32. We're going to point it at that payload.dll that we have, and then give it the entry point, which for this DLL export, the entry point of that is going to be absolute client main. Once you press enter on that, if you still have a Scythe test open, you should get a check-in. So inside of Scythe, if you this, it's a little hard on the screen when I'm sharing. Um, so if you didn't close out of the screen you had before, it'll automatically take you into the test view. But if you had closed out of that or moved it, no big deal. Just click on tests on that little sidebar over there. And then in there, your test should show this arrow. Click the arrow, and then you should have your machine here. Like I said, it looks a little strange on my screen because I'm have a split view over here. I can zoom out a little bit. So you should see this once that run DLL32 executes. Is everybody able to get to this part and get the implant to check in? Alrighty. If you didn't and you need some help, please let us know. We can remote into your boxes as well to kind of help you along if you need it. The only other piece I'll say on this, so all of those steps we ran via PowerShell on the endpoint itself, right over here. Now we have the ability because we have this C2 implant to run these next commands through the shell in Scythe. So to access that, you want to click those three lines and then click shell. So all that that's going to do is open up a Scythe shell, and now we can execute our commands on the endpoint. You'll be able to tell. I'll just kind of jump ahead to who am I real quick. All of the Scythe commands, if you remember when you created the initial test, you had to load the run module. So all of the ones that you should run in Scythe will have this run beforehand, right? That's kind of how you could tell. We'll also write in there, right, if you should use PowerShell or not. Excuse me. Um, so you can go ahead and run them through Scythe. But you can do also, if you want to run them on PowerShell on the endpoint, just don't copy the run piece, and then you can just don't copy the run piece, and you'll be able to just run it in PowerShell if you would like to. Kind of either way, it's up to you, but it's a Scythe workshop, so we got to throw Scythe in there, right? So yeah, everybody able to get through that. Again, if you didn't, just let us know and we can help you out.
All right. Now, just for funsies, you can let me take the share for a second, Tyler,
Yeah, yeah, mom.
so I can show them. Just so you see it happen more than one way. I know Tyler showed you calc running the implant, but I went ahead and did two different runs. The first one from run DLL, like you guys all should have as well. That kicked off the payload we had. And then I did a second one using SCP and just did a proxy command calling the payload that we used curl to pull down earlier. And that kicked off a secondary shell. The one thing that's interesting about this, and I would note, you notice that it still actively has my session hung. So if you close out of this window, it'll potentially kill that process and knock you off. So it's something to be aware of there. But yeah, I got a quick execution of our implant and payload by using SCP. That's something you could easily do as well. It's a cool little trick to utilize too if you ever find yourself on a purple team engagement or a pen test and all like the common methodologies for execution are blocked. This could be an easy win. Yeah, I just wanted to show that off for a second.
No worries. I'm trying to figure out how to switch. There we go. I had moved over the weekend. My computer setup is a little weird right now. I'm not all the way figured out. Okay, let me go ahead and reshare. Yeah, just on that. Yeah, the SCP thing was something that Trey found last week, and we've been messing around with it a little bit. We were a little excited about it. It's pretty sweet. Can't wait to try it out in a real engagement.
It is really interesting because it's definitely something that most people aren't going to have in any kind of like app locker policy or anything like that. So it should be an easy win here for a little while at least.
At least for a little while. All right, there we go. Got my screen set up. Okay, so on to the next section is going to be discovery, right? So you think from an adversarial perspective, they got on the box, however they got you to execute those commands, right? Maybe they socially engineered you, maybe it was click fix, maybe it was what the other version of click fix is that I can't think of what the name is. But
Crash fix.
Crash fix. Thank you. Yeah. Social engineered watering hole, phishing email, however they got you to execute those commands, they now have a C2 implant communicating back to them. So what do they want to do? They want to know, they want to do some discovery and figure out kind of who they are, what they can do, different pieces like that. So adversary 101, who am I? Right? That's what adversaries run when they get on endpoints. So we'll go ahead and execute this in the lab here in a little bit, but some other kind of ways you can determine who you are outside of who am I, or some additional ways too, is who am I with the flags of priv and groups. So it'll give you a little more information. You can also do who am I slash all, and that'll give you everything. Be able to get a little more context into who you are, right? You're thinking you're an adversaries on there. They don't really know what's happening, right? If you have a watering hole site, you're just getting implants coming back to you. You don't have, like, you're not targeting anybody. So that's what they're going to do initially, is see what they're able to do, what permissions they have, things like that. Some alternate discovery methods to determine who they are is running something like net user or net group, which will give you a little more details. Particularly if you have the domain flag at the end, that'll obviously query the domain other than just the local host you're on. And then kind of honorable mention that we always like to include is there is a lot of different ways that adversaries are um, able to get the information that they want, right? So in here we're showing like who am I, net user. A lot of those will have detections built around them, but they can also do something simply like doing some variable enumeration, right? So if you run who am I and you run echo username, user domain, you're going to get the same information, but those are two different contexts, two different detections you would have to see those two different things. So honorable mention that we just like to always throw out is there's always or not always, but there's often another way that an adversary can do something. So after they find out who they are, they want to know what's around them, right? Doing some local discovery, or some remote discovery and seeing who is around them, what else, what other machines are in the environment, what can they touch, what domains do they trust, pieces like that. So kind of the tried and true IP config to see what their networking information is, what the DNS gateway, different pieces like that. ARP is a great way to see what machines are around you, what machines are connected, and the last time that they've been connected. Because if it's a stale ARP connection, then they've probably been offline for a little bit. NL test domain trust, going to show you what trust you have in the environment, which is useful if you're trying to laterally move or see what else outside of the domain you're in that you're able to access or talk to. And then net views to be able to see the host in the domain, and then the NS lookup at the bottom to be able to find what the domain controller is. You see at the end, it's got that domain in those greater than less than symbols. So you would need to run your NetView domain beforehand to then be able to ascertain what your domain is and replace that. On there for what's running. So we know who we are, we know what's around us, now we want to know what's on the endpoint itself. So in here, just some simple ways to run to try to see what processes are running. So a couple different ways via task list or WIMIC. You would run the detections for WIMIC or WMI are different because they're stored in a different location in the logs. So you might see an adversary using either one of those. They're doing that probably most likely to see if you have any antivirus running or any kind of processes that maybe would tip them off to what services you have on the endpoint, what security tools you have, or if it's something you're running that's vulnerable that adversary could then use, try to escalate privileges or just, kind of do different pieces like that. Also have NetStart, which is going to tell you what services are currently on and running. And then SC query, see what services you have. WIMIC product to see all of the software that's installed. You could also look at that through the registry, and then looking at the installed applications or software through the HKLM, which is local machine, Hive key local machine software to see what all is installed on that endpoint. So after you've done that, you want to this is more of an addition to the who's around me. So previously you could see who was around you. Now you want to know what you can reach, what you can do a little more hands-on. So net shares to see what shares you have and net use to do the same thing. Also utilize these commands to map a network share. We're not at that point yet, but typically that's what you would see afterwards, utilizing mapped network shares to laterally move and do pieces like that. iCackles, I see ACLS is how you check permissions on a folder or a file, rather. So you can see, are you able to access this? You can also manipulate permissions through iCackles if you're trying to keep a file from being deleted or the local user trying to keep them from being able to edit or manipulate the file. And then doing some find strings, looking for password, looking for get, looking for any kind of keywords that would be inside of credentials or excuse me, looking for any kind of keywords that would be inside of the of any files. And then with that, you can specify what files you want them to look in. So if you just do a star at the end, it's going to look for a long time, right? Because it has to open every file that you have and read inside of it, see if it matches anything. It's essentially grep, but for Windows. So it probably is in your best interest to specify some kind of file extension or folder or something like that. And then the last one will look through all the files inside of C users for if it has pass in the file name. So a little different than find string, which will look inside the files. Doing the directory listing with those switches will just see if it's in the file name itself. Which could also be a good way to find some files and things like that. People have their passwords.csv saved on their desktop, which happens all the time. It's going to have password in the name, and it's a lot faster than having it look through all the files itself to find the password string inside of it.
One thing to take a note here, guys. Um, we're kind of showing you the really basic wall bin that's going on here, like the net uses, net shares, things like that. But these aren't the only way to accomplish this task, right? Tyler kind of hinted at it earlier. Those are kind of the command prompt variant of how you could, hunt for map network drives and shares. But if you wanted to do this from, say, a PowerShell context, you could use the get tech SMB share, get tech SMB mappings, things like that, using that kind of like subject verb
Yep.
matchup that PowerShell has as its own variants of these same commands or binaries. So those could be one of those kind of things too, where maybe your team has a detection put in place for net share, but nothing watching like get dash SMB and any of its variants. So these are all potential routes and from a defensive perspective, gaps that might be in your detections.
Yeah, for sure. I mean, even just on this one, so Trey had called out two examples. Even on this slide too, find string, you could do that in PowerShell with a select string. You do like a get content on a folder. You could do a get content on a folder, do a select string for password at the end of it, and then for that directory listing you have down there, you could also just do a get child item and then do a select string for pass as well. So pretty much that's a great call out, Trey. Pretty much all of these have a way you can do it in PowerShell, obviously. And then the detections for that would be different if you're just doing keyword based detections. So yeah, great call out. Yeah, so that takes us into the labs. Uh, yeah, so for this one, we will go over through. I don't think I'm sharing my screen. 1 second. Sweet. So, oh, there we go. Now my screen changed. So for this piece, we're just going to go ahead into the next section and go through discovery and data collection from overview to what can I reach. Um, Again, I know we didn't have a ton of detections in the first part. We're kind of glossing over them again, just because of time. We've already gone through an hour and we've got a bunch more stuff to go over, so we're kind of glossing over it. But um, a Splunk instance is available in the lab environment. It's going to be in that same tab, or excuse me, it's going to be another bookmark in Chrome. So if you do want to run some of these detections or translate these Sigma rules or anything like that, feel free to. We just, again, I think we probably put a little more in here than we had intended to for 3 hours, so we're just going to kind of gloss over them a little bit.
It's hard to
Yeah,
pare down what you think's important, you know.
yeah. So, yeah, so we'll do the discovery and data collection piece of it. What do we put on the time for this, Trey? 15 minutes? 10 minutes? Yeah, these are kind of simple, so we didn't do anything super crazy on there. So we'll do about 10 minutes on it. We'll go over, talk about it a little bit, and then we'll move on to privilege escalation. And then all of these commands, again, I know I said it before, all of these commands, they're predicated with the run. So you can run all of these through your Scythe shell, which I can maybe show one more time if I can find it. Yeah, which again, once it comes up here in a second, from that test on the left, if you close out of it, hit the drop down, hit your host name, and then these 3 lines, and then shell. And then in there, you can just copy paste these once it syncs. You'll be able to get it returned to you in there. So we'll leave about 10 minutes on the clock. So that'll be let's call it 2:15 Eastern time. And we'll check back in, go over it, and then move on from there. Again, any questions or not errors, any questions or anything that's broken or anything like that, please just throw it in the chat so we can get those fixed as soon as possible.
So who else still working at the moment? Anybody running into any issues?
Hopefully not. Things are good for Josh. Every time I see your last name, I think of Mike Trout from Breaking Bad and Better Call Saul. Yeah, I'm about to say, I'm sure that you have heard that before, but every time I see it, that's what I think of. No half measures. What a show. Okay. Yeah, that I'll just do a quick little demo on some of these. I said none of the discovery stuff is super, super crazy. Um, but just going through again the who am I's, a bunch of different ways to kind of ascertain who you are, if you will. I always like to say that people kind of joke that who am I is a silly detection, but normal users don't run who am I on endpoints, right? Just admins, adversaries, and nerds, right? Nobody else runs who am I on the endpoint. So while people joke that it's not a super great detection because of how simple it is, I disagree. But that's just my 2 cents. So in here, yeah, like I said you could grab some of these and run them through Scythe or run them through PowerShell. If you take the run off of it, one I wanted to point out on here is this priv. So we're going to do, I think next actually is privilege escalation, where we'll compare what the privs are between the two of them. So if you notice on this, we're just, even though this user is an admin user, we're not running this in an admin context. You can also, this is not a living off the land. This is not a living off the land technique, but you can utilize the controller we have inside of Scythe to see what level permissions you have. So again, just to kind of verify that we are a standard user. Um, so in there, oh, the mailman just came. Sorry. Um, so in there, we were looking at what privileges we had, who we are, different pieces like that. One I like to call out too is it again utilizing this run CMDC echoing some different um, variables that we have. Echoing username and user domain gives you essentially the same information you get with who am I from two completely different detections. So just something to be aware of. And then just kind of quickly while we're on it, talk about Sigma rules and how to convert them. So Sigma rules are a detection format. You can write your detection rules in. I won't get super into it. We have a whole 4 hour. We actually our workshop on Sigma is longer than this workshop. It's about 4 hours long. But for this, you have Sigma rules. It's looking at this detection piece here. If you go over to your Unicorn host box and go to Sig Converter, it will pop up here. Hit this little dial, change it to version 301. The newest version has some error, I guess. You can paste your rule down there. Make sure your target is Splunk. Sigma will allow you to translate it to any of these different languages or tools. But we're just going to use Splunk in this because we have it in the environment. It'll translate your rule down here into an actual Splunk search that you can run, and then go over to Splunk again, just in the in this tab, and then you can copy paste that in there. Leave all the defaults. It's just a lab environment, so it doesn't really matter that we don't have the index or source type or anything like that. And then you could see if your rule is going to detect this activity that we're doing, right? So we see here command line. We're looking for if it has net, or excuse me, if it has who am I with priv, groups, or all in there as the flags, or net with group or domain in it, and then we can see that we do have hits. Again, you can see like we ran who am I, that popped, but our other method of ascertaining who we are via this CMD echoing out the variables didn't hit, right? Because we're not calling who am I. So just wanted to quickly kind of go over that. If you are curious about translating the rules or doing the detections or anything like that, that's how you do it. And it should be in the overview as well up here at the top in the getting started if you want to know some more information about it. So that one for who we are, and then over to the what's around me. Again, just gonna kind of just show some of these so you guys can see what they look like. Some different commands in there. Net view domain comes up on this. Some of these take a little while because they have to, anytime you do like the / domain or anything like that, it has to query the domain controller. So it can take a little bit of time to run. List of servers not available. Oh, I think for NetView domain you have to be an admin. So that'll be an interesting one we could run again when we elevate our privileges here. Yeah, for some of our rules and such. And then over to what's running, what's happening. Let's do a quick SVC, see what services are excuse me, what processes are running and what services they're associated with. And here, so if any of these are associated to a service like LSAS was started by these different services you have on there, it could be very interesting to see from an adversarial perspective into what's running and what service owns it, because maybe you want to like LSAS up here, if you know that these services are going to query or spawn LSAS, which is where your password or not passwords, which stores your credentials for the logged on user, handles the credentials for the logged on user. You probably maybe want to exploit LSAS in some way. So knowing what services and what processes are associated can be very valuable. Um,
The other interesting thing here with that task list is, well, actually, with all of them on this page, is they might seem like low impact. This might seem like, yeah, yeah, whatever. They're just looking for information. Without looking for information, it could be a big tipping point for you as a defender trying to catch them in the middle of their kill chain. But from an adversarial perspective, if I'm landing on a net new host and I'm not sure where I'm at, who I have as context, or even like what defensive tooling is in place, this is a quick and easy route to do it. We've seen it in CTI before where they're doing the simple running task list to validate the defensive tooling, your EDRs, all those different processes that are in place. They're looking at the registry. They're doing these very simple behaviors because they're effective. They work and they're usually low fidelity when it comes to kicking off alerts and things like that.
yeah, really great. Kind of to more on that, the discovery commands themselves, like Trey's saying, are pretty low fidelity alerts. I think other than who am I, right? I think that that is a bigger deal than people make of it. Um, but like in and of themselves, they're not super high fidelity because it's just kind of like a discovery command. You're not changing anything or doing anything. But if you're able to put in like if X amount of discovery commands are ran in whatever your threshold is, right? If someone is doing an automated campaign or LLM generated campaign that runs at machine speed, it's going to run these commands within a few seconds or even like milliseconds of each other, depending on how they set it up. So if you see, net share, who am I, IP get SMB share, a bunch of these different discovery commands we're talking about. If you see all those running within 30 seconds of each other, probably is, or not probably, that is a much higher fidelity rule, because that in and of itself of it running so many times in a short time span is odd, right? Normal admins don't do that, right? That's something that scripts do, automated campaigns do, or adversaries quickly trying to identify who they are, where they are, what they can reach, et cetera, et cetera. So yeah, just some more just going through. I know we had already kind of talked about these, checking the permissions if you want, hunting for password credentials and things like that. Not sure. We didn't stage anything in here. We didn't stage any in this lab that would return this, but I think there might be some in the lab that return it anyway. So I'll let that run as we're kind of going through it. CMD key is very interesting. So it allows you to save your credentials. I'm gonna run it through here while Scythe runs. So in here, so we have two service created ones. So not something you'd be able to utilize, but it can save like your remote desktop username and passwords, different pieces like that. And then you're able to then utilize these essentially saved passwords to run as that user without having to know what the actual password is. So super useful. I would yeah, I'd be curious if you guys ran this on your own endpoints that you're on right now, this CMD key / list, if there was anything, interesting or valuable in there. We've seen quite a few of them in some of the Purple Team engagements that we run that people don't even know that they're being saved, right? Some services just automatically save things as you're running them. So something to be aware of.
But kind of the new norm there too in the age of AI, it's been really interesting to see some of the variables or other things they're writing to command key as well that you may not even be aware of.
Yeah. So super interesting. And CMD key was very, very prominent back in like the pre-Windows 7 days. Now it's not utilized quite as much, but still, again, a lot of services will write to your CMD key. Your RDP connections, MSTSC will write to your CMD keys. So something again, just to kind of be aware of. I would run it on my endpoint and see if anything comes up. But that takes us through discovery. So, any questions? Anybody run into any issues or have anything happen? And we have some guided questions here at the bottom, but I think maybe we'll save those for some more interesting sections. All right. Well, that Trey, I will toss it back over to you. Maybe if I can find the screen share. Um, Actually, no, I'll do this next. This is only one slide for the next one. I can do this next one. So we don't have to switch back and forth.
Makes sense. Easy enough. So this one's a fun one.
Alrighty. So over to privilege escalation. Here we just have one example. There are many examples of privilege escalation through LOLBAS techniques. The issue with them, I guess, well, I can leave it on this screen. The issue with the privilege escalation techniques through LOLBAS is most of them get patched pretty quickly. It kind of your mileage varies on some of these different privilege escalation techniques that they have. I would encourage you guys to check out the LOLOL farm or the LOLBAS project to see what some of the other ones are. Maybe try those out in your environment or in this lab machine. If you have some more time or feel the need to. But for this lab or for this piece of it, we're just going to use FOD helper, FOD helper. What that is set to do is I'm drawing a blank on what the FOD
Features
stands
on
for.
demand.
Features on demand. Thank you. So this one is not patched, right? Because it's designed to do this, right? It's designed to launch these things when you run FOD helper. It's a feature, right? Not a it's a feature, not an exploit, right? But we can abuse it anyway. So to use it, it really is very, very simple. You just need to set two registry keys. We'll set two registry keys and then run FOD helper, FOD helper. So the two registry keys you set in this example, we have cmd.exe, and then we're setting the delegate execute to force, right? So that F to be able to add it or to have it in here to then capture whatever is is above it. So all you have to do to get this to run your implant, we're going to do in the lab environment is we're going to replace this cmd.exe with our payload.exe that we downloaded earlier. And then when you run FOD helper, you will get another check-in on Scythe, but that second check-in, the permissions should be different. So it yeah, very, very powerful. You don't need to be admin to run these to set these keys. One thing to point out is because it's HKCU, which is current user, where LM is local machine. HKCU for current user means that it's just for your user account, which is why you're able to modify these registry values without having to be an admin. So with that, yeah, let's
As a little
jump
bit of
into the lab.
context,
Oh,
as
good.
a little bit of context there too, that features on demand executable, what it's working as, basically like when you go into the settings, go to apps and features like that. When you go to install, like say a new language pack or like OpenSSH, some other kind of application, that's what the operating system is using behind the scenes is FOD helper to do that. So that's why it needs that ability to kind of auto elevate because it's attempting an install of a new app or feature. And that's something that threat actors, late 2010s have been taken advantage of at a
Yep.
minimum.
Yep. So definitely a high fidelity one that you definitely want to be on the lookout. And then just real quick before we go, you can see that my find string for password finally came back. It took a long time because there is a lot of files that have a password inside of it. I doubt any of these are actual passwords. It's probably just like a a variable that's being held or a comment or something like that. But that's what it would look like if you search through it. And this is just a lab machine, so searching through a real machine or a real endpoint looking for all these is probably going to take a very, very long time. So it would more than likely they would specify like a user directory or program files or something like that to be able to find it. Um, and then kind of what after you read these and run through these, what you should see inside of this, and we'll get to it when we do the demo. But after you launch FOD Helper over here, if you back out of the test that you're in, you should see another test execution was ran, and so you can switch to the other test execution. If it doesn't come up, just go back to tests, hit the drop down, then you should have another one pop up here, and then run that privilege command we showed a little while ago. That who am I priv that we specify here and just kind of compare what the permissions are. We'll be able to verify if it works or if it didn't work. So with that, we'll do about another 10 minutes or so for you guys to go through this. So about 2:40 Eastern time, we'll check in and see how everybody's doing.
How's everybody doing with this one? You're all able to get a new shell back with Bot Helper?
All
Anybody need
right.
a few more minutes to go through this, or you guys good?
Just gonna show on this one again real quick, just make sure everybody was able to get them. Make the screen bigger for it to resize. Yeah, if you're in your lab instance and it's like stuck on a smaller screen, even after you make it bigger, if you just refresh the whole window, it'll make it a normal size. So in there, just like we'd shown in the lab manual, right, we're going to add this registry key for the payload. Zoom in a little bit. It's a little too much. Going to add this registry key to add the payload.exe, and then we'll add this registry key to tell it delegate execute, which is going to give us our admin permissions. And then we're just going to run FOD helper. We're going to run it with the CMDC beforehand. The reason for that is so it doesn't tie up the terminal. So if you run FOD helper on its own, it's just going to hang while it launches the other process. So running it as CMDC is going to essentially detach the process so that way our shell doesn't get hung. From that, after, I don't know, maybe about 30 seconds or so, 10, 15, 30 seconds, if you hit the drop down, you'll see that you have another unicorn host implant that you are able to interact with. So if we switch over to that one, see it runs the who am I the same as before because that's the automated piece of the campaign. And then we run that who am I / priv. We see zoom this down that we have a lot more privileges here than we did when we ran it before in our standard shell. We just had those two privileges in there. And then just to do kind of a double verify again, not a LOLBAS, but it's it's a LOLBAS as far as the C2 is concerned. Just running that controller integrity to see what level integrity we have or what level our implant is. So we were at a medium before, and we are at a high now, which means that we are now an admin. So going completely living off the land from a standard user, two registry changes, running one living off the land binary, and now we have an admin shell that we can do some more stuff in. So with that, if there are no questions, then I will drop it for Trey.
All right. So up to this point, we got our initial execution on the user. We turned around, did a little bit of discovery, then we set up some privilege escalation, kind of make sure we can do what we need to do. Now it is time to talk about persisting. We've elevated our access. We've got our kind of hooks into the system. Now let's make sure we can stay and survive a reboot or some potential other issues. Now, this is going to be one of those sections we run through, and you guys are like, well, duh, of course, those are the way they're doing persistence. But again, this is one of those things where these um, these tools, these behaviors, they work, and they work well for a reason even now. First one up, we're going to kind of talk about from a persistence perspective of scheduled tasks, right? I'm sure you guys all understand what these are. Basically, puts in a rule or a command and says, hey, do this certain thing at this certain time. That could be run at a specific time, run when a specific trigger happens, run at reboots, all of those different kind of behaviors. This is still kind of a tried and true method, and it still works. We're still seeing it in new and relevant CTI, and I'm pretty sure if you go back and look at the original Conti playbook that got leaked well over a decade ago, they were doing some form of persistence through scheduled tasks. So the way this is pretty easy in the way it works too, when you're looking at it, the first one there is basically just we're creating like a quick little, we'll call this schedule task Windows update helper. Sounds benign, sounds legit. Nobody's going to really care about it. And that's going to turn around and have a trigger function to go and run our payload. And the ideal goal here is this gives us that callback or our shell back at a system level context when the persistence happens. Same thing on the two below them. We've got one set to run as a timer, renamed it something, like Microsoft Edge Sync. All of these sound kind of plausible. Then lastly, just for you to kind of check and see what's there and kind of blend in, you can look at the scheduled task and query it using that string that's down there. There's nothing really crazy happening here. There's no like real secret sauce to it. Scheduled tasks are simple but effective. Next two, we'll talk through. So registry, so using the run keys. Who in here hasn't heard of the run keys yet built into Windows systems? So you typically usually have two different sets that are in there, a current user and local machine that are it's run and run once. What these are is they're basically a point in the registry where you can go in here and add a specific object. What's the word I'm looking for here? A value. So that's what I was looking for, a key or a value within that registry and have it do a particular trigger. In this instance, we're going to want to set it in the lab to have it run our payload and give us a callback or a new shell. We can do that from that per user level. So this doesn't require you to have admin, and you do that through HKCU, so current user registry sets. Or you can do it from a system-wide persistence level, which requires those admin or elevated privileges, which would be under local machine. As you're playing with registry going through this lab, I would say try both ways. See which one works from your Scythe shell that has your user context, and then see which ones work or if it works any different from your new elevated context you just got from FOD Helper. And then lastly, the one we're going to talk about here, since we're talking living off the land only, we're not doing anything crazy with boss or stuff like that, is service creation. We can turn around here, kind of set up a window service that starts automatically. We can have it run as system by default. And the cool thing about services, these will typically survive a reboot, right? So creating them super easy. We're going to use the SC binary. So SC query, start, create, all of those are a function out of SC. And as you can see from what we have on the slides here, creating one is super simple. Just give it a name, tell it where the service binary exists and how you want it to start. You can give it a quick manual start just using SC start and then call the new service by the name you specified. And then you can query them and find your specific one using that SC query that's down there. I know they're kind of simple, but that's kind of the genius within it, right? And the benefit of living off of the land. It's not requiring any kind of complex tooling. It's not requiring us to bring anything in outside of that payload that we wanted to execute to give us our shell. Did you guys have any questions through these three? So the end goal by the end of this next lab is, now that you have your kind of privilege escalation, is to utilize one of these to now set some hooks into the platform for you and give you some persistence. Yep, all good. Sounds right. Yeah, again, they're nothing crazy, but they're still worth talking about because we still see this happening today, and we still utilize these in Purple Team engagements, and they work. So, I mean, we'll stop talking about them when they stop working. So, with that, then let's move into this next lab. This one should be another quick one, so 10-15 minutes, and then we can start rounding the day out with our last two sections, which would be defense evasion. And then the last two or three defense evasions, some credential access, and impact. That's when it starts to kind of get fun. Everything up to this point is kind of build up and staging for us to impose some kind of effect on the endpointer in the organization. So it is 2:48 now. We'll round to 2:50. I'll say we can do a quick check-in at 5 after and see how you guys are doing. Again, go ahead and give one or more of these different ways a try. Try it from both shells that you have so you can see the difference in how they run. And if you have the time and the ability, go ahead and look in Splunk and see if there's a difference in how those events appear. So we'll check back in. Yeah, we'll say 5 after. Sound good? All right. How's everybody doing with this one? Anybody need a few more minutes? Or are you guys good to move on? Sounds like everybody's good to go then. Let's do the thing. So open this guy up. Let's hop in the shell here. Boom. Quick validation, who I am. Yep, unicorn. So we talked through three kind of main things we were doing here. That was scheduled tasks, registry keys, and service creation for persistence. These are pretty straightforward when we're setting them. This first one here, quick, we'll show it. We'd be doing the scheduled task creation. With this string, what we're kind of showing it is, hey, we want to create a net new scheduled task. We're calling it Microsoft Edge Sync. Its trigger is to run the command payload.exe, which is from our implant we downloaded earlier in public. We've got it set to run hourly. I forget what /mo was. Tyler, was that?
Um, Drawing a blank.
Yeah, same. So that one tripped me up. I'll find that one again here in a minute. And then we're telling it to also kind of run a system and go through and do this. Creating the scheduled tasks are all fairly easy. If you need to validate, this one's telling me I can't do it. I don't have the right actual permissions, which makes sense. I'm not running from that FOD helper shell like you guys potentially are. I didn't demo that one. Tyler did, so that is my bad. Sorry about that, guys. But we can keep on moving on. Did anybody run into issues doing the scheduled tasks one at all? So you guys shouldn't have run into the same error as me unless you didn't elevate your context at all.
Yeah.
For the
And
reg,
the MO is the modifier, so how often it runs. So you have it set to hourly, and then MO for 4 is every 4 hours.
there we go.
Just
That's
like
right.
totally drew a blank on it, and then I was like, duh.
I did too. I did too. I was like, oh, what's going on here?
Yeah.
Whoops. Well, the next one was registry keys. With this one, you can see we're going to current user, not local machine, because we're doing this from a user context. I'm setting that run key there. The interesting thing with these, I would note from the administrative perspective, you have two different run keys. You can kind of utilize that run or the run once. What's cool about the run once is it'll do exactly like it says. It'll run once and then clean itself up. So that'll go away. What we're doing here is we're doing a real quick set and run to make a new key called Windows Helper. That key is going to have a value of run this payload, so payload.exe. Hit there. So at the next run, it'll turn around and kick that off for us. And then as you guys saw in the task, you can query these and they'll come through just fine. The last one was creating a service. With that, we're telling you just call it sysmon helper, where the binary is and how we want it to start. And querying those is pretty easy. Ooh, why did I get a failed 5 on that one? Ooh, context, right? Yep, because I did not elevate. Sorry about that. But run sc. Let's do a quick QC. Here it wants me to give it a name. So, don't you love the demo guides, guys? I completely blew that one by not doing FOD helper. But anyways,
It's always one.
Yep, one had to get me. It's been a minute. So normally, if you follow the actual steps in the lab, like we built them out properly, it normally works fine. My context isn't elevated, so it wouldn't work the same as you guys's are. But one thing I would want to kind of talk through and note, and it was one of the guided questions here, why would we prefer to modify something that's already in place as opposed to creating net new like we did here? Does anybody have an idea on that? So, like, as an example, why would it be better for me to modify an existing kind of service that's set in place as opposed to creating a whole net new service? Yeah, the potential for logging catching it. I would also think about the changes in state to the host, right? Those changes are kind of super easy counters and things to watch and wait. If you know typically how many or what services are running on the disk, and all of a sudden a net new service appears, or even let's say we do like a new user creation, then add them to a group with your more controlled groups like domain admins, people that have local administrator rights, things like that. It's kind of a good practice to know who has those permissions and what your typical counts are. So if all of a sudden, let's say today your domain admins are six in your organization, but tomorrow you have eight, it's a real easy tip off that something's going on, right? Either A, which is probably unlikely that you hired two new admins and immediately gave them domain admin over a day, or B, somebody's doing something a little fishy. So by turning around here and just kind of modifying these services or modifying something that's already in place, we're potentially lowering our visibility profile and making it so that we don't stand out as much. These are still really good state-based changes though. So like adding something to a run key, new scheduled tasks, those kinds of things, especially if they weren't there before and it's not a typical behavior you see your admins doing, it's a real good tip off that someone's potentially setting persistence. Anything you wanted to add on those, Tyler?
No, I think good points. Yeah, definitely, it's a lot easier or it's a lot stealthier and harder to detect the modifications than creating like a net new something. Like you said, you can have like a counter that counts how many services you have if a new service is installed or a new scheduled task is created or something like that. Makes it a lot easier to find it if you're looking at it that way, where if you modify it, let's say you have a service or a scheduled task or service, whichever I guess, that's Microsoft update or something like that that you see run every day. If you see it running and you're not like monitoring for what the values are of what it's running, if you modify it, it's going to be a lot harder to detect because it's just something that you see all the time. One that I did want to share as well before we go on. I'm just going to share my whole screen.
Yep, go for it.
Hopefully, nothing crazy happens. Doo-doo-doo. Um, One point I did want to point out. So after I made the scheduled tasks, I went into the task scheduler itself just to verify that it was there and kind of take a look at it. So in this process, there were two scheduled tasks that we created, but I looked at it, when I went in here and looked at it, I was like, all of these look pretty much the same, right? It's like all of these four scheduled tasks um, don't look super malicious or anomalous or anything like that. Like I kind of forgot what I called the scheduled tasks when I made them. So the two that we made are this Microsoft Edge Sync and the Microsoft Update Helper. But the Microsoft Edge Update Task Machine Core or UA, they all look pretty much the same. So it's kind of the power of trying to blend in. Again, all of this probably seems super obvious, like duh, like obviously that's what you want to do. But when you're actually doing it, it doesn't always seem so obvious to have things named like this. But these really blend in pretty well. Like we don't have descriptions on these, so that's a pretty good, maybe not a good detection, but something you can look out for something that's odd or different. Is that these don't have descriptions, but you can also add descriptions into these when you create them. Another great one too is the author, like you had pointed out. So here you could see that Scythe Unicorn is the author of it, but it could be that this Ideally, adversaries are trying to get to the admin account, right? Admin accounts are the ones that make scheduled tasks or services or processes or install programs are what make scheduled tasks. So if you're an admin and that admin is make like if, from doing some enumeration or discovery or pieces like that, you find an user that typically makes scheduled tasks or things like that, maybe that's who you want to um, impersonate or the credentials you want to grab to try to blend in even more. Um, you know, it's, Never mind. I was gonna say you don't see as much of adversaries trying to blend in and stay in like dwell time longer, but that's what Vault Typhoon does, right? Their dwell time is years, where like ransomware actors like they don't really have a dwell time because they're just trying to go in and perform ransomware. But so there are still indicators that you could pull from here, but just like a quick look, these look pretty innocuous, right? So just something I wanted to point out, that just like the power in simplicity and the power of trying to blend in is definitely there. But that go over to defense evasion. So by defense evasion in this, we just mean getting in there and um, utilizing defense evasion to try to make the investigation or the recovery process more difficult for the organization that we've infiltrated and done our actions on objectives on. So getting into defense evasion, the first one up is event log clearing, right? So you can use WEVT util to clear event logs. There's also a PowerShell commandlet. I think it literally is clear dash event log. Excuse me. Where you go in and clear the event logs out, so that way they'll have a little bit more of a difficult time trying to hunt through it. This again kind of well, we haven't talked about it yet, but this highlights really the power of having a seam in your environment and having your logs forwarded to your seam. Because even if an adversary gets onto the box and clears the event logs, if those logs are being forwarded to your seam, then you don't really have to worry about it because you're getting those logs anyway, right? But maybe to kind of connects some dots. Maybe when they were looking at the processes earlier on, they saw that you have a Splunk universal forwarder or WinLog Beats or Elastic Agent or something like that that is utilized to forward logs. And maybe they killed that service or they killed that process. And then after they killed the process, they did some stuff and then they cleared the event logs. Then you wouldn't have any logs to be able to kind of hunt through. One point on the event log clearing as well is there is still a log that the event log is cleared, right? So if you clear the event log, you will still have an 1102 security log event cleared or event log cleared. 1102 is for the security event log. But so there will be something that still points you that this thing happened. So something to be aware of, probably a pretty good detection to have in there, pretty high fidelity, because it's not too often that an admin would have a legitimate use to clear out your event logs. So that 1102 is definitely something that you want to be cognizant of. And then the FSUtil USN unique serial number, something like that, journal deletion. So this journal, what it does is logs all of the file modifications that happen on the endpoint, right? So if you can delete that journal, this is another DFIR artifact that they're not going to have, right? They're not going to be able to hunt through. So definitely pretty powerful on that one. Boy, my keys aren't working. I gotta use the scroll on my mouse. And I think the last one before we get back into the lab is the disabling of Defender. So this is not like MDE Microsoft Defender for endpoint. This is like Windows Defender on the endpoint itself, disabling real-time monitoring, disabling tamper protection, which is difficult, and we talk a little bit about that in the lab, that without tamper protection being disabled, there are certain things that you're not able to do. But disabling real-time monitoring you can do as an admin, and adding the exclusion paths you can do just as an admin, right? So if you're able to go onto that box, disable real-time monitoring, means that your any other executables or implants or things like that that you dropped aren't going to be scanned. That should be pretty loud, pretty high fidelity detection there, because that should not be something that normally happens, as well as adding that exclusion paths. Then that way you can essentially download things to a certain directory or run certain commands in directories that are not going to be flagged. These are super high fidelity alerts, definitely something that you want to monitor. These are really great too because you can look at them at two different ways, or several ways, but you can look at it from a keyword based detection of looking at like if they literally run reg add Windows Defender and be able to hunt on that. But let's say they base 64 encode that command line argument, right? Your keyword based detections aren't going to pick up on that. So what kind of the good piece of this as well is because this requires registry changes. No matter how you do it, it's going to change these registry values. So because it's going to change these registry values, a higher fidelity alert or higher fidelity detection for this is going to be just monitoring for registry changes to these registry values, right? So if your exclusion path registry key has new values or changed values, it's going to be event ID 13, I believe, is modification. If you see that, that's a high fidelity state based change that happened. So you can disable Defender, using PowerShell command line arguments for like um, what I think it's literally like disable dash real time monitoring or something like that. So you can do it through PowerShell and through other means, but no matter how you do it, it has to write these registry values. So monitoring for these registry values is a much, much better detection and alert because you can't change that, right? Where keyword based detections you can easily evade with base 64 encoding or messing with the process hierarchy. Like if you ran these commands through that SEP proxy bypass we had shown you a little earlier today, right? Those keyword-based detections might not hit on it, but those state-based detections of these registries being modified will hit.
From a threat perspective, what's interesting about this is sometimes these steps may not even be necessary. And we've seen it a lot in recent CTI to where they're going after like your major EDRs. And the reason I say it's not necessary is a lot of the times when you install something, like CrowdStrike or another bigger name tool, it typically has a requirement or it'll go in and do it itself where it turns off real-time monitoring and tamper protection and all of the others. Because a lot of the times the two tools will end up fighting and conflicting with each other over like who's alerting, who's taking action first, who's doing a thing, and it starts causing problems. We've seen it on live engagements where someone's running, say, like Sentinel One and Defender and some other tool, and now all of their tools are in this like never-ending battle of who's going to do something, and it ends up messing up a lot of the alerts and the investigation paths, or just causing things to never actually fire. Or we've even seen it to where it'll cause like Sentinel One to fire. Sentinel One will say it did a thing, but because Defender kind of hooked first and tried to take action but then failed, nothing ever happens. And a great example of that is like, say, we put a payload on disk. Sentinel One and Defender at the same time decide they don't like the payload, but because they both kind of conflicted, neither did anything about it, but both report that it was quarantined and cleared. But then our payload still exists and runs just fine. So in more kind of modern setups, and a lot of times now you'll see that Defender, if they're running another EDR or another like bigger dumb defensive tool, they'll just go ahead and turn all of these off. So you don't really have to worry about it.
No. Yeah, seeing them like fight over each other is pretty hilarious, and happens quite a bit. Yeah. So with that, yeah, we'll get back into the lab, which is going to take us, I think, almost all the way through. What else do we have here? So that'll take us through the defense evasion piece, and then we just have credential access and impact after that, and then we'll be done. So we're should be like right on time, pretty much through this. Let's do 10 minutes for this, and we'll check on everybody. So three, we'll do 3:30, and see where everyone's at. So that way we're able to make sure that we get through all of these. So about 8-10 minutes or so, and see how everyone's doing.
So I know you guys are working through the lab at the moment, since we were kind of on the topic of um, blinding or kind of disabling defensive tooling. I dropped two links into the chat. This is one of the kind of more interesting ways I've seen lately where people are finding a way to effectively blind like your EDR and AV tooling and those kinds of things, utilizing the built-in QoS ability inside of Windows itself. That second link I posted is a link back to the Hag. He gives you a quick route, which is really interesting to look at, to utilize PowerShell to write a QoS for any of those main like big vendor tools. So all in all, it's pretty cool. It's doing a simple like a get content and looking at a list basically, and for any of those objects in that list, it's going to set a new QoS policy using the like new -net QoS policy commandlet. And all that list is all of the service process names for the major, AV, EDR, SIEMs, like those kinds of things. And by doing that, they're not really killing the service, they're allowing it to function and run, but none of that telemetry ever makes it back to, the SaaS platform that you typically operate from. So it's a pretty interesting pathway to do some of these similar functions and behaviors. I just wanted to mention that for a second because it is really interesting some of the ways people are figuring out how to get around your security tooling.
Yeah, Josh, the list.txt, I'm pretty sure that that is it's either oh, there you go. Never mind. It's a list that he has inside of the GitHub repo in there that has a bunch of the services that it looks for, like Trey said. So it basically just instead of listing out all the different services or processes like in an array, it just has it in a list and then it loops through it. See if I can find the GitHub repo. Sure, a lot of people are pretty familiar with the Hag with Michael Haggis, but he comes out with some really great stuff. Just started a new, it's like magic something. Hold on, I just saw it a minute ago. Magic Sword. Yeah, I actually saw it when I went to the LOLOL.farm site and had an ad for it at the top. Um, yeah, it comes out with some really cool stuff. All right, go ahead and share my screen. Just again, just running a little bit on time. Want to make sure we get through it all. Oh, Zoom is being so weird. I feel like I say that every time that we use Zoom. All right, I'm just in there. Some of the defense evasion, just some pieces of it I wanted to point out. We did mention time stopping in the first one, but honestly, it just seemed kind of silly, so we took it out. But you can do time stopping on the different file names and stuff if that's what you want to do. Scroll up. It's like a little bit of a lag. So the first one in here was just listing out either security system on PowerShell or system event logs that exist, right? Just something an adversary might do to see which logs do you have that I might want to disable or clear, something like that. So we get a pretty long list of different log sources we have available here. Going to go in, going to clear the security log out, you would see, and then doing this query here to pull the last 5 events that we have, we see that there's only one event, and that's actually that 1102, which is that the security event log has been cleared that we had talked about, and then you could go in Splunk 2, and I just did a quick query in there for 1102 or 104, which is system. Again, really this should not be happening too often in your environment, so it should be a pretty high fidelity detection or alert that you have on there. And then next up, the utilizing fsutil to delete the journal. So in there, you first do a query. Really, the point of querying it is to prove that it did get deleted. So do a query first for the journal on the C drive. We see that the ID ends in echo 8. Then we'll go in, we'll delete the journal for the C drive, and then we see that the new one that's created is 0 Charlie. So we see that the old one was deleted, the new one was created. It gets created on its own. There's nothing. Actually, there might be a way to turn it off. I'm not sure, but it gets created on its own automatically. So as soon as you delete it, you'll see that a new one gets made via that event ID. And then next one in there was disabling Defender. The I am running in an admin context, like you can see here, this high mandatory level when I did the controller in integrity. But when I put in the exclusion path in the beginning, I got access is denied, which kind of made me chuckle because I was trying to figure out why it was denied, and then I remember that I put a note in there of why it was denied because it happened when we were testing. So if you have tamper protection on, it will not allow you to do the exclusion paths. So you first have to turn tamper protection off, which requires system level permissions, not high level permissions, and then from there you would be able to set an exclusion path. So just an interesting little tidbit in there. It is a little more difficult. Well, I guess once you're admin, it's not too much more difficult to get system, but that is a piece in there just to be aware of. So because that had failed, I switched back to just disabling real-time monitoring, which was successful, but again, much louder when you do it that way because that should really be an alert if someone disables real-time monitoring. Even if you have additional systems on there, additional EDRs or pieces like that, it's probably something that you want to be aware of if your local defenses get disabled. Yeah, and then that I just go on to the next one for potential access. So with the potential access, we're going to essentially extract some registry values inside of here. But then we would take offline. We actually don't talk about doing the exfiltration of these in this piece. We do exfiltration in the next section. But essentially, you're going to do a registry save of the SAM and the system registry hive. Inside of the SAM and system registry hive are or inside of the SAM file is like kind of an older way to store credentials for local users and pieces like that. And then you need the system registry hive because it has the way to decrypt it. So the SAM is encrypted, like it should be, right? It stores some NTLM hashes in there for local user accounts. So you need both the SAM and the system dumps to be able to decrypt and then grab those NTLM hashes to be able to do like
You need a boot
the
key.
boot key. That's what it is. I was like, yeah. So you need both of those to be able to then crack them offline using something like secrets dump, SAM dump, Jack the Ripper. Maybe that was really popular a long time ago. Utilizing some of those different offensive tools to be able to do that. But dumping out or saving the registry hive is pretty simple. You just run reg save and you tell it what you want to save and where you want it to save to. I've actually got some pretty good luck in we run this quite a bit in PTEs. Probably every PTE that we do, we run these. We have some pretty good luck just changing the output file from sam.hive to sam.txt. So even just sometimes, again, there's beauty in the simplicity of it, right? Just changing small things that people are alerting on or detecting on, or if they make a rule that's super specific to something, you can easily evade it by just changing things a little bit around, right? You can output this file, call it whatever you want, and then upload it, change the name back, and then be able to access it, right? So something to just kind of be aware of if you are on the blue team and writing detections and pieces like that. If your detections are too specific to something, they can easily be evaded by just making a very, very small change. Yeah, then we have you can run in package secrets dump. We don't have that downloaded to disk, but if you have time and you want to, you could download that and then run it on the lab environment and see what you get. And then we're to ntds.dit extraction. So this is on the domain controller. So for this part, we are going to have to switch from the Unicorn host to the domain controller because we didn't put any kind of like lateral movement in this in this workshop. So we'll do this in PowerShell on the DC when you switch over there. But the ntds.dit file is really kind of the holy grail of what you're looking for, right? It's not quite as good as like getting a golden ticket, but it's got the whole Active Directory database in there. So if you can crack this, it's got, I mean, all of the Active Directory information, users, computers, trusts, everything. If you can pull this off and extract it, or exfiltrate it rather, and look through it, you really can enumerate and have total control of the environment. So really something you really want to take a look at. Um, you, it is you have to have additional tooling to pull out the ntds.dit file from where it lives on the environment. So a way around that, not having to bring it in, is to create a shadow copy. What a shadow copy is essentially a backup that lives on the server, right? So you're going to create a shadow copy of the C drive, and then from there, we're going to actually copy out the ntds.dit file from that shadow copy. So that way, it bypasses the file lock. You don't have to download any additional tools or anything like that. You can just create the shadow copy. You need to be admin to do it, but create the shadow copy and then pull files out of it that way. Excuse me. And then while we're in there, we'll also grab the system hive. The reason for that, again, is because the system hive has that decryption key, that boot file in there that you're going to need to decrypt the ntds.dit file. And
This
then,
is one that can be really interesting. From I'm probably saying the 3 years of PTEs we've done, I don't think we've seen anybody that actually effectively utilizes shadow copies anymore. They're always using some kind of offline backup or other tooling for backup services. So this could be a pretty high fidelity detection for you guys, especially if you know in your environment VSS is turned off, like you don't have shadow copies at all, and all of a sudden they start appearing on disk somewhere. It's worth looking into.
yeah, that's a good call out. We get a little more into it in the exfiltration piece of it, but Um, threat actors, you'll see often will attempt to delete or clear all of the shadow copies that you have. And I always thought that was, I don't know, not silly, but not too many places use shadow copies anymore. Like Trey said, you have an offline tool or you have another, the when you can't change it, the im oh man, I'm drawing a blank today. The
Immutable.
Immutable, thank you. They'll have like an immutable backup or something like that. There's not too often that you really see people using shadow copies anymore, but it still exists and it's a great use for something like this to get around like file locks and things like that. Yeah, so that'll take us into credential access. Trey, do you want? I think I should just wrap up the rest of the slides real quick, and then we'll do the rest in the lab time in about
Yeah, yeah, let's
20
push
minutes.
it, then we can demo it all together.
Okay.
So one thing we did for you guys as well, we know this was a lot of content. The webinar itself ends at 4 p.m. Eastern time, but we slated an extra hour of lab access for you. So those VMs and everything will exist until right around 5 p.m. Eastern today. So if you wanted to take the next hour after the webinar is done to continue playing with Scythe or doing any of these behaviors, you have that ability.
Yes, and then also um, on the last part of the lab manual, we downloaded the slides as a PDF, so you could grab those too. And then okay, so kind of getting to the impacts on objectives to the really juicy part, right? So we got on the box via whatever, probably social engineering of some sort, right? That's how it most often happens. So we get on the box, we found out who we were, what was around us, what domain we were on, the users, we were able to elevate privileges. We did some defense evasion, covered our tracks a little bit. Now we're going to do our actions on objectives, the impact, and then do some exfiltration as well. So first up, oh look at that, VSS shadow copy deletion. Again, not sure really how practical it is anymore, but adversaries still do it, so there's got to be somebody out there that's still using shadow copies for stuff. Um, Again, someone deleting a shadow copy is a high fidelity alert that should not be happening in a normal kind of cadence. So seeing that is definitely a high fidelity alert. It's very simple to do. You just run that command. There's also a backup catalog, which catalogs the different events and files and things like that you have. It's essentially just another backup. And then there are recovery environments that can be enabled. This I do see being enabled, having that recovery mode. You might even have a recovery mode like on your personal computer if you hit like the Windows key and type recovery. That's what this is, right? So a lot of places do have recovery enabled, even for like standard, just normal PCs you have at home. So you can disable that as well. So this really is akin to when we see ransomware threat actors doing, which is they don't want you to have any kind of backup or any way to restore the files that they're encrypting, right? Because that's their whole thing. That's how they get paid. So really, if you see any of these, pretty high fidelity alert, unless it's a normal occurrence, but again, probably shouldn't be in your environment. Um, this will, I more than likely, you can escalate this to an incident pretty much immediately as soon as you see something like this. If this happens, it that's pretty bad news bears.
And it's one of those things too where like it does seem like it's a little outdated, but even as recent as in the last 3 to 6 months, groups like Chillin or any like the IRGC kind of related Nexus actors, and even to an extent like Akira and Lockbit with some of their wiper payloads and things like that, they're going in and checking and deleting VSS, like doing shadow copy deletion and things like that. So it again, it might seem simplistic, it might seem a little dated, but here, even just in the last few months, there's still notable intelligence showing that these ransomware groups and other Nexus actors are doing it.
Yep. Oh, show. And then over to data staging and archiving. This is normally just a precursor to exfiltration, right? So in there, some different ways to stage files. Here we use Xcopy and Robocopy. Robocopy is really better for larger files. Um, Excuse me, sorry. Robocopy is better for larger files. It's faster and knows like what state it's on. But either way, you could also just use like copy tag item in PowerShell to be able to copy things over. So after that, you're going to make an archive of these files. We have in here make cab, which will make a cabinet file, which is a built-in like Windows file, Windows compression file essentially. The issue with that is you can only make a cab of a file, not like of a folder or of the contents of a folder. So in the lab, we actually use PowerShell compress archive to create our compressed archive, our zip file of everything, because I didn't want to run make cab 100 times because you can only run it, like I said, per file. So just something to be aware of. And then we have a way down there to decompress or to expand that archive out. So once we have our data staged and compressed, then the next step is to exfil that sucker out of there. So there's a couple different ways that you can do it. This is not even, an exhaustive list of the different ways that you can do it. But what we see most often in CTI and in practice is utilizing cert util. So the same way, or excuse me, utilizing cert util one to encode everything in space 64. The reason you would do that again is so it's more difficult for them to see what is being exfiltrated, right? If they have some kind of DLP control or something like that, a DLP control is not going um, to undo your base 64, right? It's just going to send that file or that content through. But to actually do the upload, you can do it via bits, background intelligence transfer service. Um, have that, you need to have an HTTP server that is available and allows for uploads. Or what we see most commonly is just using curl, right? So we use curl initially to download stuff. You can also use curl to upload things. There are tons of public file hosting sites that are available that you can exfil things to. You can exfil to pastebin. That's a common one that we use. Ugu, which is one that we're going to use in the lab. Transfer.sh, file.io. I mean, all kinds of different sites. You can stand your own up. It's not too difficult either. But yeah, utilizing curl is probably most commonly what we see, and that's what we'll be doing in the lab. And then be that going to finish out the rest of these slides real quick. So from the defender's perspective of all the things that we ran, I know in the slides we talk about detection, or excuse me, in the lab, we talked about detections and how to see it, but just some different pieces of what the adversary had done all the way through. So utilizing SCP, run DLL32, and curl for that initial execution, using some of these discovery commands, privilege escalation, utilizing FOD helper. You can also use run as or changing some registry values, but they're not as stealthy, a little more difficult. Like for run as, you need to know what the credentials actually are. So we didn't include them in the lab environment. But persistence over to scheduled tasks, again, that registry modification of the run keys or creating services. Uh, Evasion, clearing out the different logs and journals and things like that, making it harder to kind of reconstruct what the adversary did. And then we get over to credential access. For that, we have the saving of the registry values and the ntds.dit file, and then extracting those out, running them through an offline parser of some sort to be able to extract those credentials or those hashes out. Impact, we have deleting the shadow copies. We had doing the file staging and pieces like that. Impact 2, there's really only kind of so much impact that you can do with living off the land. Like if this was a ransomware emulation at this point, for the impact, they would probably use curl or something like that to download their binary that they want to run to perform the ransomware or to perform over the ransomware, or if your impact is to steal stuff or do exfiltration or different pieces like that, that's when all that would happen. And then exfil, which is still actually under impact, under actions on objectives, utilizing certain util to base 64 encode our file that we want to exfil out of there, and using bitsadmin and curl to actually move that file to our likely to our C2 or whatever file storage online site that we're using. And then again, in this, all of these commands here, like other than us running the C2 implant, that payload.exe or that payload.dll, everything else we did is like we don't have to bring anything else in. Everything else just exists in the environment on the endpoints. We're able to use them. Everything is signed by Microsoft. There's no custom malware or anything like that that we're doing in here. All of this stuff is just utilizing what's available to us in the environment.
What's really
Ah,
interesting on that slide, as he's going through all of these, you could pretty much pick and pull any one of these from each piece of this kill chain. And I guarantee if you threw a dart at a bunch of CTI, the chains are all going to look kind of similar to what we have here.
yeah.
The variations you would see realistic, it would be like instead of you bringing in your own C2, RMM use. It's so prevalent nowadays, seeing things like AnyDesk or I mean, pick your RMM, right? Those kinds of tools would be the easiest way of having control. And then you really don't even need to bring in a C2 that could do all of these behaviors, issue all of these commands directly through that RMM, bring their own tooling in if they want, things like that. So
Well,
it's
that and we see too of just like having RMM, like that's a lot of the social engineering things, like hey, download any desk or whatever. But if you can get them um to allow for your RDP connection, then you can just do it all through there. Then you're really living off the land all the way from the beginning, right? If you can convince them to like you can create an RDP saved file, that's you convince them to double click on that and give you access to it, then you really don't have to bring in anything. You can do everything completely just off of what Microsoft gives you. All right. And then what to log and what to alert on. Some high fidelity alerts in there, right? That shadow copy being deleted. Really, any kind of shadow copy logs, excuse me, that journal, anything like that being deleted. something you definitely want to take a look at. Registries being saved and TDS.dit file being accessed at all, right? Being accessed by anything, something you definitely want to take a look at. And then some high fidelity logs, like, right, you want to know the processes, the network connections, files being created, and the registries being modified, logs being cleared. And then if you utilize Defender, have Defender on, um, having the Defender operational logs being turned on so you know like more specifically what's happening in there, and then the Bits client for any of those file transfers being done. Bits client is definitely not something that we see enabled in a lot of places. So it's really adversaries like to use it because people aren't looking at it, right? They're just looking at like that process creation being made. But like we had talked about, there's a lot of ways around that. Just simply base64 encoding things or renaming bits admin, like just doing a copy item bits admin to bits not admin, right? And then running it that way is going to change the image, change the process hierarchy, and all that. So something to be aware of. Some
Though
key. Oh, yeah, Trey.
I would say there's probably one saved round, and it was something we didn't do in this workshop was user kind of creation or modification.
Mm.
And that was something I would add to this list. We're still seeing it, and quite often where they'll come in and they'll modify a user to add them to different groups or create their own user and make them a local admin, things like that. So if you're watching kind of your more protected groups in your organization, anyone that's going to have some kind of privilege to affect change, understanding the users that are in that group, having some kind of alert when the count in those groups changes could be a quick, easy win as well.
Yeah, for sure. Yeah, that's a good one. Could definitely add that in under persistence, creating those users, having backup users, things like that. Yeah, that's a good call out. Yeah, we should have had that in here. Just some key resources. We have these listed out on in the lab manual at the end as well, so I won't really go over those. State-based detections, I've said it a bunch of times, definitely better than keyword-based detections. Just like behavioral patterns of things being done in a certain time frame, or your process hierarchy being different, things like that. Know your environment. You're not going to be able to find these anomalies if you can't determine that they are anomalous, right? So knowing your environment, threat hunt as often as you can, forward your logs to a scene, and then that's it. So yeah, thanks everybody for hopping on. Close, come on, close that. Got about 10 minutes left that Trey and I will stay on, but we have said two more sections here for the credential access and the impact. And then in the wrap up, we have the slides themselves and the CPE if you need it. It's for 3 hours, and then some of the resources down here. So yeah, Trey and I will stay on for about another 10 minutes or so with you guys. If we've got any questions or anything like that before we hop off, please let us know. Yeah, the lab environment should be good for another hour or so you can continue to go through it. Yeah, thanks everybody for hopping on.
Do you guys have any outstanding questions or things you wanted to chat through while you're finishing up the lab today? Thank you very much for that. And this one was fun to put together.
So this is the first time that we're doing this one. We talk a lot about living off the land stuff, and like I said, it does seem like very simple, right? Like there's nothing super crazy happening here. It does seem super simple, but if you guys are reading any kind of CTI, it's what they do, right? Why would you bring in something if you don't have to? So
Yeah,
if all
why burn time and money and effort on R&D of some kind of custom payload that's just going to get flagged when you
yes,
can work with what's already in the environment?
yep, we see a lot that pretty much any exe from the internet is being flagged or blocked by something, right? If you download it like from Chrome, um, Safe Search is gonna kill it, or at least warn you about it, right? So don't Lord. Yeah, it's very difficult to get like additional pieces on there. At least like through traditional sources like through Chrome or like normal file downloads, you can get around it a little bit with curl because it doesn't have that mark of the web. But anyway, so using the living off the land techniques as EDRs and AV get more, I don't want to say sophisticated, but as they kill things quicker, using living off the land is really the way to do it. It's the best way to get around all of these things.
Any last second questions, things you guys want to chat about before we hop off here for the day? And again, thanks for joining us. If you guys like this kind of content, please let us know, whether that's through an email, through the little help in core stack, or on social media. We can keep building more stuff along these lines. And this was kind of an inch deep, a mile wide when it comes to living off the land. I mean, there's a half dozen other things in each phase of the kill chain we could have potentially talked about today. And these are always fun. So we like to make what you guys want to see and what you guys want to learn about. Just let us know.
When you said if you like this and like you had a little pause, I thought for a second I've been listening to my son watch YouTube videos all day. I thought you were gonna say smash that subscribe button. I was gonna be like, I'm out, I'm done, I'm out of here. I
Nah.
really thought this was your fast way. That's funny. Okay. Yeah, yeah. Again, yeah, just to echo what Trey said, thanks everybody for hopping on. I'm gonna end this here in a second. Hope to see you guys at the next one. Don't, yeah, Josh, don't forget to like and